Okay, guys, so sorry I'm out today. I'm just getting some rest. I'm running my first marathon on Sunday. I'm trying to decide if I'll be here on Monday or not. We will see. But we're going to go ahead and be in 7.3. So if you're not in those notes yet, let's get there. Just like yesterday, we were talking about similarity. We're trying to see if triangles are similar or not. And then if so, state how you know. So that's going to be these three cases over here that I have written. So SAS is side, angle, side, or side, 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 or side, angle, angle, angle. So one of these three cases would help us prove that two triangles would be similar, okay? So the first step with each of these, I would look at, is there an angle that they have in common? Well, by these markings here on number 1, I do have one angle in common. Oh, that's a gross looking N. So I have one angle in common. So that means I'm probably going to be side, angle, side, but we need to check the sides to see. So in order to check the sides, we need to see if they're proportional. So if you guys remember from yesterday, we were looking, be careful with these because this 30 is going to correlate with the 70. It's like they turned the triangle on us, right? So I'm going to have 30 over, well, you could do 30 over 70, or we could do 30 over 27. But the 30 and the 70 need to be across from each other. And then the 27 and the 63 need to be across from each other. Okay, now in order to see if these are proportional, cross multiply. And sure enough, if I multiply these, it would have 1,890 is equal to 1,890. Okay, so these are in fact similar. And how did I know? Well, it's from side, angle, side. Because the two sets of sides that share an angle, share the same angle, are proportional, that is how I know. Okay, so now this little statement down here, this right here means similar, this little like squiggly line. Okay, so the order on these letters does matter. So if I go U to V to W, the letter that corresponds with U would be D. So it'd be triangle D to E to F. So that would be what's called the similarity statement, would be this right here. Okay. Now, see if we're looking at number 2. First thing we want to do, we do have an angle in common. So we have one angle in common. Now we're going to check the sides. So let's see, if I put 9 over 21, let's put 9 over 21, is that going to be equal to 6 over 15? Well, let's see. I don't think so, but we shall see. If I multiply 9 times 15, that's going to give me 135. And if I take 21 times 6, that gives me 126. So those are not equal, so these are not similar. When they're not similar, you don't have to fill in that statement right there. So that's all we would be looking for. Okay, moving on to the next one. I'm going to erase some of this so we got some of the mess out of the way and we're not too jumbled up. Okay, so with this one, I want us to notice how these are connected. These two angles here and here are vertical angles, which we should know from part A of geometry. And vertical angles are always congruent. So those two angles are equal, and I also have angle B is equal to angle V. So I have two angles in common. And when this happens, it's automatically similar by angle, okay? So if I have at least two angles in common, that means it's going to be similar. Now for my similarity statement, A to B to C corresponds with A to V to U. So triangle A, V, U would finish that similarity statement, okay? So let's try another one. This time, we're gonna have to check all three sides on this one to see if it's side, 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 because I don't know about the angles. So I have 0 angles in common, right? So let's check the sides. So this time we're gonna have to set up multiple proportions. So I'm gonna do 56 over 12. So I'm gonna use the corresponding sides to set up proportions, okay? Now if I do the longest sides, 98 over 21. And I'm gonna see if that's equal to 84 over 18 by using 84 and 18, okay? Now, if I were to divide each of these, 56 divided by 12 is 4.6 repeating, and I'm using a calculator for that. And if I take 98 divided by 21, it's also 4.6 repeating. And if I take 84 divided by 18, it's also 4.6 repeating. So what this means is they are similar, and this is by side, side, side. So since all three sets of sides are similar, that's when we can use the side, side, side theorem. And then for our similarity statement, JKL corresponds with FED. So that's going to be the order of my letters there for that one. Okay, just a couple more. Stay with me. So here we need to find the missing length. Okay, so the question mark, that's our X here, right? So if we're looking on the smaller triangle, like the one that's on the inside, okay, that's going to be in green. We are going to be using the 18 and the 24 here. So I'm going to put the shorter side over the longer side. And I'm going to see if that's equal to the larger triangle, which I will be using X and 32. So I'm going to have X over 32. And so I would have then 24x is equal to 576. And if I divide both sides by 24, x would be equal to 24. Okay, so notice how I didn't even use the 33 or 34, or 33 or 44. You could have, if you wanted to, but like instead of using the 24 and 32, we could have used the 33 and 34. It's all in relativity of the corresponding sides, okay? Now, if these two are similar, what am I looking at? I am trying to find x here. So if I'm looking at the smaller triangle, I have 6 and 6. So I'm going to go ahead and put 6 over 6 and see if that is equal to x over 30. Well, 180 equals 6x by cross multiplying. X would have to be equal to 30 as well. Now you probably could have noticed that if you're like, oh, well, these two sides are the same, then these two have to be the same, but it's always good just to double check, okay? What you could have also done is set up your proportion as 6 over 30 equals 6 over x. That would have given us the same answer. Okay, for these last two problems, solve for x. The triangles are similar in each pair. Okay, so if we're looking at these down here, here's what we're going to do. We are going to look at our corresponding sides. So I'm going to go ahead and put 14 and 21 on the top of my proportions. And then I'm going to put the 36 and 2x minus 4. Now be careful which one you're putting where, because the one that should be under the 14 is the one that's on the same triangle, the 2x minus 4. And the one that should be underneath the 21 is the 36. Okay, so we're going to cross multiply again. Don't forget to distribute. If I take 36 times 14, that's 504. And I'm going to set that equal to 21 times 2x minus 4. Remember to distribute, okay? So that would be 42x minus 84. Add the 84 over. I would have 588 equals 42x. And if I divide by 42, x is equal to 14. Okay? And then last but not least, here we go. Trying to find the x value. So I'm going to look on the smaller triangle. I've got 10 is going to correspond with the 3x over 1. 14 corresponds with the 49. So here's what we're going to do. We are going to we could put the longer side over the shorter. Let's do that. So if I'm putting longer over shorter, that's what that would look like. And now I'm going to cross multiply. I would have 490 is equal to 42x minus 14. Remember to distribute that 14. And now I'm going to solve for x. So 504 would be equal to 42x. Dividing both sides by 42, x is equal to 12. Now, if there's any of those that you need to go back and maybe look over, feel free to email me with any questions that you guys might have. But make sure to have this on Monday to turn in. Okay? Hope you guys enjoy your weekend. Have a good Friday, and I will see you when I get back.